In these videos, we want to introduce how Desmos, an online graphing tool, can be used in place of a physical graphing calculator for some of the technology components of Math 95. What we're going to do is skip around through some of the different activities, specifically focusing on the portions that would use technology to show how this tool can be used as a replacement. So in Activity 1.7, we're going to go ahead and jump ahead to questions 10 and 11, which relate to completing a table of values using technology. In question 11, our textbook is giving us directions on how we could complete that using a graphing calculator. But what we'll do instead is flip over to Desmos, which you can access at desmos.com. In order to start graphing, all we have to do is click the Start Graphing button. There are options to create an account or sign in, which you're welcome to do if you already have an account or want to save some of the work that you complete. But to start from a blank canvas, all we have to do is click that Start Graphing button. Since we want to construct a table of values, what we'll do is click on the plus sign and add a table here. And we'll see that we're given a table with two columns, x1 and y1. If we flip back over to our problem, we'll see though that our given variable here is p. So one thing that we can do if we want to start manipulating things a little bit more is actually change our x variable to a p if that's something that you want to do for consistency's sake with the problem that you're given, or we can keep things in terms of x. And then we can go ahead and plug in those different given values for p. So 2, if we click down, another row will open up, 2.5, 3, 3.5, and 4. So nothing right now has happened with our second column. Since the way this table is set up right now, it's expecting us to enter in another row of points or another row of values. Instead, what we'll do here is delete this y1. So rather than the second column being a variable, we'll just delete that and type in our given function, which is 12.6 times p1. So replacing that column header with this formula that we want to evaluate auto-populates that second column, giving us our formula evaluated for each of those different values of p. As soon as we complete this, both of these columns, our points are already being plotted. However, we might not see those right away if our domain and range aren't quite accurate for our graph. So what we can do is use the plus and minus buttons over in the corner, and we can zoom out on our graph until we start to see those points show up. So now what we can actually see are all 5 of those points being plotted on our graph. And if we want, we could continue adding more values to continue that pattern. If we skip ahead in Activity 1.7, in question 12, now we'll be asked to actually graph the given function, that y equals 12.6x. So skipping back over to Desmos, we can go ahead and do that by just clicking on a new cell here, and we could either type this in as y equals 12.6x, or if we wanted to, we could type this in using the variables that are actually contextual in the problem. So c equals 12.6 times p. In either case, we see that our line starts showing up as soon as we complete that equation. If we wanted to, we can go back, and anywhere we have one of these colored circles, we can turn different features that we're graphing on and off. So for instance, if we wanted to hide that graph or hide those points, we can do that. If you click and hold on any of these, we can change the colors of things to manipulate them. If we're going after any certain visual effect, we can graph dashed lines, solid lines, as a problem might require. So in question 12, we're asked to graph that equation, but we're also asked to graph it giving certain dimensions for our graph, a certain domain and range. So we can enter these exact values into Desmos by clicking on the wrench icon up in the corner. And what we can do is enter in our minimum and maximum values for x and y. So in this case, we want x to go from 0 to 4 with a step of 1, or an x scale of 1. We want our y-axis to go from 0 to 65 with a step of 10. And now we have a graph that mirrors that picture that we're being told we should find. In 13.a, we're going to be asked to determine reasonable window settings for the graph of our function, for which the domain is any real number. skipping ahead to 13.b, we have the values that we should come up with in that resulting graph. So what we can do is go ahead and update our graph to match these results by again clicking on that wrench icon and changing our minimum and maximum x values. And you can also skip between these different fields by pressing the tab button. I'm going to change this from, I'm just entering the same values again. Let me make sure I'm entering the right values here. So this should be from -10 to 10 with an x scale of 5. And our y value should go from -25 to 25 with a y scale of 5. So now what we end up with is a resulting graph that looks like what we're seeing in question 13, part B. In question 14, we're asked to essentially repeat some of these same steps. We're given a new scenario, and we want to, in part C, complete a new table of values. So to start this additional work, we can do one of a few things. We could just work on top of what's already here, or we could choose to turn off all of our existing values if we want to hide that previous work just to see the new material, or we can delete everything that we've completed so far by clicking these X's, and now we again just have a blank slate to begin working. So since what we want to do is complete a new table of values, we could again construct that table. If we wanted to change our variables to match what's in the problem, this would be h1 would be our independent variable. And then the formula that we would come up with in part A would be 10.5 times h1. And then we can just go about completing our table. So for h1 we would have the value 0, and then again using the tab key we can jump through the different fields here. And we can complete that table of values based off that formula that we would determine in question 14.a.